Welcome back to the channel. Today we're going to take a look at a trig equation involving tangent. For some reason tangent scares students, so I thought I would do one with tangent. Also throw in a double angle and put in secant, which works good with tan. A couple of ways to go here. I do find students tend to be a little bit nervous around tan. Please don't be. What I would recommend that you know is the relationship that tan and secant share. Don't forget those little ideas. You know, we know that sine squared plus cos squared is equal to 1. That's your basic trig identity, your Pythagorean identity. And if I was to divide by cos squared, cos squared, cos squared, then you can see you're going to get tan squared plus 1 equals secant squared. Just abbreviating here. So you can see here that tan squared is going to be secant squared minus 1. And so what I could do here is sub out the tan squared. And by the way, it works for any angle, so you just have to use the double angle. So I'm going to erase this, and I'm going to do the sub here. I'm going to say, well, that there is secant squared 2 theta minus 1 minus 4 secant 2 theta plus 5 equals 0. Some students, because they really get into the habit of turning everything to sines and coses, this could be written as sine squared over cos squared. This could be written as 1 over cos. You could multiply through, clear the denominator. You could do that, but it would be extra work, I think. All right, so here, secant squared 2 theta minus 4 secant 2 theta, and the negative 1 plus 5 gives me a positive 4 equals 0. I'm going to solve for secant 2 theta using the quadratic formula, which is going to be 4 plus or minus the square root of b squared, which is 16 minus 4, times a, which is 1, times c. And you can see that's actually 0, meaning that this was factorable, right? There are two numbers at times to give 4 and I to give negative 4. So you could have factorized all over 2a, which is 2, and that's just going to go to 0. So that means that I'm looking for angles for which the secant of 2 times that angle will give me 2. Well, if secant 2 theta is equal to 2, then I know that cosine double is equal to 1/2. And if that's what I'm after, then maybe what I'll do is I'll take 2 theta and sort of think of it as a single angle A. And I'll locate where my answers are. I know that this is the x-coordinate. It's positive, meaning I'm in the first and the fourth quadrants. I'll think of my special triangles because these look like special side lengths, which they are, root 3. So there's my reference angle for angle A, which is going to be pi over 3. So for A, I get basically two answers, pi over 3, and I also get 5 pi over 3, 2 pi minus pi over 3. So I'll put the 2 theta back. Okay, so 2 theta is equal to that, meaning that theta is going to be pi by 6 and 5 pi over 6. I have to be careful though too, because tan and secant carry restrictions, but I know that these are not restricted values because for this we're going to be looking at quarters of a pi. But you should always verify that your answers balance the original equation, because sometimes you get something known as non-permissible values or restricted values, so you need to check them. These answers, I meant to indicate too that I'm only interested in answers. I only want answers between 0 and pi. Okay? And these answers are between 0 and pi, so I don't have to generate any other answers off of them. All right, there's our trig question for today. A little review for some of you, I don't know. If you liked the video, make sure that you put a like on it and subscribe for goodness sake if you haven't already. And I'll see you right back here in the next video.